behavior in graphing. So you're looking at polynomials that may have certain degrees or highest degrees. So this is polynomial with a highest degree of 2. You can have 1 that goes on maybe a little further, where you have a highest degree of 4, and then you could have polynomials which you're graphing. Probably easiest just putting on a TI-83, 84, or some sort of graphing calculator. But there are some things that you want to look at. I put these dots here to show that there's an x4, or may not be some x's in between. Okay? It's just kind of some of the end behavior and what the graph should look like. So if you have an even degree polynomial, which is what this is, 2 and 4, an even degree. Okay? And the leading coefficient here, this part in the beginning, okay, is positive, then you're looking at, let's look at, we'll say even positive. You're looking at the end behavior starting from the top and finishing at the top. You could have a polynomial with x to the 50 and have a certain set of choices, and because you know it's a leading coefficient positive and it's even, and you see the one graph starts here and finishes here, you can determine, okay, that's my graph. You also have an even negative, and a lot of this we've seen with the parabolas that we've worked on. Okay? This is where the leading coefficient is even, and you have a result when it's positive, result when it's negative. If you have a leading coefficient odd, a positive graph would start in one direction. It may have a few max and mins and finish in a different direction. Okay? These values depend a lot on what you have in between your leading coefficient and your constant here. And then a negative would look something like this.
Thank you.
This is a really good kind of just skill to have, or maybe not a skill, just something that you have in your tool set that where you can recognize and just pick graphs off, especially when you're doing some sort of standardized testing and they're giving you something like this. Eliminating answer choices is a great tool to use. Now, if you have to graph any sort of polynomial, okay, I know right away, because this is odd positive, my graph is going to look something like this, right? And I could put this into my y equals function of my TI-83 calculator, and it'll give me what the graph looks like, and I could also use a zero function to find my zeros. And you could also do it by hand, where you're going to factor out the x, which is what we've been working on. And then you can x plus 2, x plus 1. This is my unfoil of this. That gives me zeros of 0. Remember, if it's plus 2, I'm going to subtract 2 to get to 0. So it becomes a negative, And I can go to my graph, and I can go to my 0, and I can go to my -1, and I can go to my -2. Let's say 0, -1, -2. And I can start some of my end behavior saying, okay, I'm going to start here, come back to my other 0, and then finish positive here, where maybe I started negative. And that's how you could graph this manually. easiest way, probably TIE on some sort of graphing calculator. But you could also factor by zeros and then be able to graph this with a sketch, and not have to take this and make some sort of table. Because the problem with the table is that you don't know where the end behavior changes, so you may have to go pretty far in either direction with your x to find where your end behavior is. Because if you did 0, 1, 2, and 3, the only part of the behavior that you're going to see is to the right of the y-axis, and that behavior is only